did remember to start the recordings. Just a couple of notes. I noticed that some of you have found the fact that there is a chat feature in our Google Drive. Please avoid using that during class, as it can be probably distracting to anybody else that's in the Google Drive looking at the same time. Also, if you do use it outside of class, be very respectful to everybody else in there. There have been instances in the past where people have been rather rude or mean to other students in the class, or just been like very flippant in what they're posting on there, and they've gotten in trouble and sent to SJ because of that. So just be respectful to everybody else here. Other thing is keep up your questions that you've been asking in class. I really enjoyed the participation. It's been doing a good job, and hopefully you're getting a lot out of it. We're going to pick up from where we left off yesterday, but there were a few things that I forgot to mention that we should do now. The first thing is that when you declare a variable, there are a couple of different modifiers that you can add on to that variable. There are more than are listed here, and we'll cover some of them later on in the class, but we probably won't cover all of them. The first is const, and this means that the value of this variable cannot change after it's been created. I did start the recording, yeah. So const means the value of the variable cannot be changed after it's been created. This can be really useful for when you have some constant, like say pi, right? You don't want its value to be changeable after it's been created. You may have some other like hard-coded constants you want to use, but it's a lot better to give them variable names than to just have the value 5 magically sitting somewhere, or the value 10. You can give it some name, but make it constant so that it can't change. There's also unsigned. This can be applied to the scalar types, which are integer, short, and char. This is going to double the maximum range of positive numbers that they can represent, but you're no longer able to represent negative numbers anymore. You probably won't need to use this one at all in the class, and you can do both at the same time. So you can have like a const unsigned integer. Both of these declarations would go before the type of the variable. So here we have an unsigned integer a. He has the value 5. A constant double b equals 3.5. The value of b can't change afterwards. If you attempt to change it, the compiler is going to give you an error that says, this thing is constant. You can't change it anymore. So it'll catch you if you accidentally make that mistake. You can have a constant unsigned short c is equal to 17. You can assign an unsigned integer a negative value. But negative values are actually treated as very large numbers by the unsigned type. It actually turns out that -1 is the representation of the largest possible integer, if it's an unsigned integer. The reason for this you'll find out when you take ECS 50. But be really careful about that, and if you do decide to use unsigned variables, which you probably shouldn't be using, if you accidentally get a negative number, it's going to turn out to be a very large number instead. Any questions so far? The other modifier that you can put on your variable is to make it a reference instead of making it a new variable. So when you declare your variable's type, you add an ampersand afterwards. And you have to make sure that when you do declare a reference, it has to be assigned to another variable when you create it. When you create a reference to a variable, you're essentially creating an alias, which is just another name for that variable. In every way, shape, and form that matters, that variable is identical to the original. There's no difference between it. If you change the reference, if you change the value of the variable through the reference, the original changes because of the same thing. If you change the original, the reference will change as well. And once you create a reference, you cannot make it refer to something else. So over here I have an integer a, who's 10, and then I create a reference to a called ref. So if I make integer b equals ref times 2, well, the ref is the exact same thing as a has the value 10, so ref is equal to 20. If I say ref equals -3, because a and ref are the exact same thing, a is also now -3. If I say a equals 7, again, since a and ref, they're the exact same thing, there's no difference. Ref is just another name for a and ref are now both 7. So like internally how it's implemented, references are like pointers that you do not have to dereference. But we'll cover pointers later on in the class. Why is what constant? Why can't you make it refer to something else? Because one of the differences between references and pointers, besides the fact that you don't have to dereference a reference, is that references cannot be made to refer to something else, but pointers could be made to refer to something else. Well, yeah, because like if you try to do something like ref equals, if we tried to do something like this, like ref equals b, this is going to be an error because it cannot be made to refer to something else. But if you had a pointer, you could make the pointer point to something else. Any other questions?
Right.
Yeah, an ampersand. Yeah. Just how you declare it. So if you want a double reference, it'd be double ampersand, right? If you want a character reference, character ampersand.
Of a different type.
It has to be the same type as the original. So an integer reference can only refer to an integer. A character reference can only refer to a character. You can't make like an integer reference refer to a double. It doesn't work. Anything else? Okay. We'll maybe talk about this later, but you've probably done some casting in Python, correct? Where you guys ever use like the int function or the float function or the stir function?
Yeah.
Right? Those are all Python's equivalents of casting. In C++, you can do it as well, but it's a little bit more limited in terms of what can be done. So if you want to cast something from one type to the other, you do static cast, desired type, and then expression that you want to cast that type. This is going to create a new variable. It doesn't change the original, right? You may have found out this like the hard way when you were doing in Python, right? If I have some variable like x and I do int of x, does x change? No, right? Same thing here. When you static cast something to a different type, the original does not change at all. Yes, these are different than functions like toInt or toString. You'll see later on that like integers are not castable to strings. Strings are not castable to integers. But there are some methods like string to integer, right, which will convert a string into an integer, or integer to string, which converts an integer to its string representation. So pretty much like the only ones you're going to be using for like right now at the beginning are between doubles and integers. I wouldn't see you using it for anything else at the moment, but later on in the class we'll might be applying it a bit more. When you convert from a double to an integer, you discard everything after the decimal point, just like you would do before. When you convert from an integer to a double, you add a 0.0 to the end. So if I had a double a who had the value 35.47, I could static cast a into an integer, and then it would be 35. I could also just say b is equal to a, and then there will be an implicit casting from the double into the integer. So this is how you would do an explicit cast, but a lot of times some implicit casting will be done for you. An example of this is when we were writing our functions yesterday for doing the areas, right? The areas of the trapezoid. Right, you guys had questions like, could we pass in integers for like long side or short side or height? You can, and they would be implicitly cast to a double when they were passed in. Right, so the type would automatically be changed. You wouldn't have to statically cast explicitly to a double before you pass it in your integer. So one thing just to point out is that C++ by default does call by value for variables, which means that when you pass a variable to a function, you get a copy of that variable's value. You don't get the original. If you change the copy inside the function, since it's a copy, the original doesn't get changed if you happen to modify it. But instead of passing by reference, passing by value, you can instead choose to pass by reference by having your function, instead of accepting just like a double or an int or a string, accept a integer reference or a character reference or a integer or double reference, and then you'll automatically get a reference to that variable instead. This would allow you to modify that variable inside the original, and the change would show up on the outside as well. Because since you have a reference, just have another name for the original. It's the exact same thing as the original. So modifications to the reference inside the function will show up outside the function as well. So if you ever need to modify a variable inside of a function, and you want that change to show up outside as well, make sure your function accepts a reference. If you only need to read the value, the conventions in C++ are if it's one of the basic data types like int, bool, double, char, just pass in an int, bool, double, char. If it's anything more complicated than that, you'd want to pass a const reference to that variable's type, which you'll see in a second. The reasons for doing this are twofold. One is that it's a lot faster to pass a reference to the variable as opposed to having to create an entire copy of it, right? If we have some list of numbers that's 100 long, and all I'm trying to do inside my function is read it, if I pass a reference to it, I have the const reference to it, I have the original, and I won't accidentally make the mistake of modifying it, but I don't have to copy everything. But if I accepted a copy of the value, I'd have to copy over all 100 elements, which could be quite time-consuming. So it'll be a lot faster then. Also, not all objects are copyable. Everything that we've talked about so far and everything we're going to talk about for a while will be copyable. If we ever get to an object whose type is not copyable, I'll make sure to point it out. So here's an example. Here might be something that you try to do where the point of this function is to set this variable to this value. But because we're just taking in integers and we're using call by value, we get copies of those values. And so all I do is I change the copy of var inside the function, and then once the function completes, the original would not be modified. So if we go down here to a, right, a is equal to 35, I print out a, we'd see 35 show up on the screen. Then I attempt to set a to 23. Well, inside this function, again, I'm not changing a, right? This variable gets a copy. Var gets a copy of a, which is 35. Value gets a copy of 23, which is 23. And then nothing happens because all I change is the copy inside the function. So I'll get 35 again. But if instead I accept a reference to the function, right, and I say var equals value, it's going to work because var is just another name for whatever happens to be passed in as the first parameter. So the first time we'd print out 35. Then if I called this version of set, I'd get 23. And then I would print 23 out at the end. Any questions here?
Having copy.
Oh, what's the point of the one on the left-hand side? It's just to show you the mistake, right? It's just to show you that by default you get a copy. And so even though your original intent was to actually change var, right, the variable that was passed in, it didn't work. Any other questions?
Or having.
So the question is, like, would it ever make sense to pass in a copy? Yes, sometimes. If you were planning to modify the argument, but you didn't want that change to show up on the outside, then making a copy of it makes sense to be passed in. But that would be about it. Anything else? Yeah. Yes, it's very similar to like passing a pointer to the function, but again, you don't have to dereference it, right? It's a lot more convenient to work with than a pointer. Because if I was working with a pointer, this would have to be like int star var equals value. Anything else? Yeah. So everything we're talking about right now is for C++. When we're going to do C++ first, and then later on in the quarter we'll get to C. And I'll tell you, basically once you know C++, you know all of C. But a lot of the C++ will tell you what C++ features don't exist in C, because C is a subset of C++. Okay, that optional arguments. I think we talked about this yesterday at the end of the day. It's kind of where we left off, is that functions don't have to have unique names. They just have to have unique signatures. But the signatures do need to be distinct enough for the compiler to be able to differentiate between the two. If they're too similar, the compiler will complain at you about these two things are too similar and I don't know which one to use. So you'd have to change the type a little bit. An example of this would be over here in function overloading. So I have a couple of different functions. So here is a function that just returns an integer, and all I do is I print out that foo was called with an integer. I can't do double foo over here because the signatures between int foo and double foo that takes no arguments, they're too similar to each other, and the compiler cannot disambiguate between the two. So I could have one or I could have the other, but I can't have both. STD is the standard template library, and everything that's contained inside the standard template library is inside the standard template namespace. So cout, which is what we're using to print to the screen, which we will talk about in a little bit, like more formally, is how you print things out to the screen. These other two functions, they're both legal to create, but they're very, very similar to each other. And I would say that they're too similar to each other for their own good, which makes it confusing as to which one might be called in a certain situation. And we'll show you in a second how to make sure that we can be very explicit about which of the two that we call. Then I have one that has 3 parameters as well. So over here, if I call the first one, right, we're going to call the one with no arguments. Over here, right, we call foo with a 12, foo with 45x, foo, right, with b56, foo with 1, 2, 3. Right? Notice that even though we call it with 1, 2, 3, we didn't make a version of foo that actually accepts 3 integers. But because integers and characters are very close to each other, and they're castable to each other, this integer will be implicitly cast into a character as it gets passed into that function. The other ones were the two that I talked about that were very similar to each other. These ones were able to we have to explicitly use like static cast this variable to a char, static cast this one to an integer to make sure that we call the character integer one, because then C will have the types of these variables. Or if I want to do it with like the integer character, I have to do the static cast over here. So if we go ahead and we try running this, so we see that the first one called just foo, the second one called char int, the second one called int char, the third one called char int int, this fifth one called char int int as well. This one over here I did char and int, so char int char to make sure the correct ones were called. You won't see any that are like that close in real life with most programs, but I just wanted to point that out because you're going to see that when we get to some of the like standard template objects, that they have a lot of the methods as overloaded, which means that there's multiple different ways of calling these functions, but with different parameters. Yeah. What's going to happen? So if we look over here, there's the ASCII table. So you can think about like each character has a numerical representation, and each numerical representation could, some numerical representations could be interpreted as characters. For example, the number 97 happens to have the same bit pattern as the character lowercase a. Right? So lowercase a and 97, they look identical to the computer. There's no difference between the two. The only difference is how they would get displayed to the screen if you printed them out.
Like characters.
So like, yes, you can switch a character to an integer by doing ORD function. Ordinal. Right, so the ORD would give you the ASCII value of that character in Python. Over here, if you just static cast it to the other one, you'll be able to interpret it as the numeric result. Well, I mean, not all numbers have a character representation. Like, for example, the number 1000 doesn't map to anything, right? And you can see that they kind of go up to about 127. The first 127 numbers between 0 and 127, they have a interpretation as a character as well. Yes? So the question is, if you pass the value 1000 for a character, will it throw an error? It depends on how you do it. If you just passed to a function that received a character the value 1000 as a literal, the compiler would probably catch it and see it as an at least give you a warning for it. If it was like you had an integer and you put the value 1000 into it, and then you pass that integer into the function, the compiler probably wouldn't catch it, but it might give you a warning about like the sizes, like, hey, an integer is bigger than a character, so you can fit more values in there. Not everything might not map over, but if you ignored that warning, then it would take the lower byte of whatever that number is and attempt to interpret it as a character. Because an integer is 4 bytes big, and so it would take the lowermost byte of that value of whatever 1000 happens to be. Oops. In Python, right, you can pretty much write whatever code you want to outside of a function, and it will work. But C++ is a lot more strict than that. Pretty much the only thing that you can write outside of a function you can put variable declarations there. These would be global variables, which are variables that would be accessible from any function. There's one copy of them. You're able to access them from inside any function. In this class, though, you're not allowed to have global variables because global variables generally speak of bad design in your code if you're using them. The reason why global variables are frowned upon in most contexts is that they make your code harder to understand. If you don't have global variables and I want to understand how a function works, I just need to read that one function, right? But if there are global variables now inside that function, I have to understand how all the other functions that utilize that global variable affect that global variable as well. So it makes things a lot more complicated to understand, right? If there's functions 1, 2, 3, and 4 that all use this global variable, and I only want to understand function 1, well, now to fully understand function 1, I also have to understand functions 2, functions 3, and functions 4, because they all utilize that same global variable, and they all might change it or interact with it in some way. There are times when global variables are needed and necessary. For example, if you're doing shared memory parallel programming, you have to use global variables then. There's no way around it, so they make sense to use there. But since we aren't doing parallel programming in this class, no global variables. The other thing that you're allowed to put are preprocessor directives, which you'll see one in a little bit, as well as function definitions. But if most of our code has to go inside of functions, right, how are we going to call these functions? Well, in C and C++, there's the main function. And in Python, right, when you have your program runs from the top down to the bottom. But in C++, once you already have your executable, it always starts at main. So wherever main is at, that's where your code begins running at. So if you want to run some of your functions, call those functions from inside main. There can only be a single function named main in a C++ program because your program can only start at one point. Right? If there are 2 main functions, how is the compiler supposed to know which one you actually want to start at? Has no idea. If you want to accept command line arguments, which we will talk about later, you would have int main, int argc, char double star argv. Argc would be the number of command line arguments you received, and argv would be the actual arguments as C strings. But again, we'll get to that a little bit later. And if you're not going to accept command line arguments, it's just going to be int main. The value that's returned by main is considered to be the success code. 0 means success. Anything else means some error happened. Whatever that error is unique to that particular program, and you have to look at that program's documentation to see what an error code of 5 meant, or 7, or 2. You just wouldn't know in the general case. Yeah. Any questions? You've kind of seen main show up here a little bit ago. Or we can actually just go to an example. Right, so here is my main function. This is where my code begins at. So I made a trapezoid whose long side was 5, whose short side was 3, and whose height was 2. And then we calculate the area of the trapezoid by calling our function, and then we print out the area of that trapezoid. So pretty much at the bottom of your main function, you're always going to need to make sure that you return 0 so that you will have completed your code successfully. If you forget to put return 0 at the end, you won't see any differences in terms of your output about your code working or not. But if you try to submit it on Codathon, Codathon will not like it that you didn't return 0, and it will think that your program crashed because it does check your return code to see if you completed successfully. Any questions about main? Yeah. Yeah, so again, this is about I/O, which we'll talk about a little bit later on. But when you're separating your variables for printing to the screen, you separate them by the 2 double arrows. Whereas like in Python, when you did print, right, your variables were separated by commas, or you like print A, comma B, comma C. Here you do print, arrow, arrow, some string, the area, and then a new line. Also, I should note that spaces are not automatically added in between the things that you're printing, so you have to make sure that they're explicitly there. So if I don't put this space right here, the area is going to run up right against the S in the is. Yes? So the question is, what's the difference between printf printing and using the cout to print? Printf has a limited set of format specifiers that it recognizes: characters, strings, doubles, integers, and some pointers, some other ones. But the arrow ones are like for formatted output, so it will know automatically how to display that variable. So since I have like a double here, it automatically knows how to display it because it has type double. Sometimes it is more convenient to use printf to display things to the screen, but other times it's more convenient to use the cout print. Cout, like the arrow operator, also allows you to make it a little bit more consistent, or if you're writing to anything that's considered to be an outstream, like a file or a string stream, you can use the same operations as well. Yeah.
How will you know that if it there's error for me? How will you know if it always returns?
So the question is, how would I know if it returned something else besides 0 if I always return 0 here? Normally what would happen is you had some specific error code that you wanted to report. When something bad happened, you'd call exit, and you'd call exit with the return code that you wanted to get back. Other things that can happen are if you have like other errors in your program that cause it to crash, for example, a segmentation fault from going out of bounds on an array access, then it will automatically give back a number for saying segmentation fault. Any other questions? So
you set them to return by the errors?
Correct. You would return the specific number, which is why your errors are specific to your program. Anything else? That's main. So import and include in Python, right? If you want something from another module, you'd say import module name. In C++, if you want something from another module header file, you would need to include it. So while import and include look very similar, they're actually slightly different, and this difference is really key. In Python, when you import a file, you say, Python interpreter, please go run all the code that's in that file. So it executes all the code that's inside that file. When you include something in C++, it means copy and paste the contents of that file into that spot. So it takes whatever's there and copies and pastes it in, which can cause quite a few differences later on when we get to some more complicated problems. The other thing is that the include statement is a preprocessor directive, and this is a command to the compiler to do something special. It's not like technically C code itself. So we're saying like back here, hey, C++ compiler, right? When you're translating this line, please copy and paste the contents of this file into my program right here. And then once it does that, it'll then go and translate whatever that C++ code was that was copied in. And again, you're probably going to end up with quite a few includes in your programs. because C++ chooses that you should only pay what you use mentality. So a lot of the common features like printing to the screen, they're not built in. You have to include the appropriate header file to be able to print to the screen. Any questions about import versus include? Yeah. The question is it possible to include only a function from a file? No. You copy and paste the entire thing. So in some of the examples, I may have just used string without including the string library. That was just to save space on the screen. So I would, to actually really be able to use it, I would have to include string. If you don't include string, you'll get compiler errors like, I don't know what a string is. If you attempt to use like the type std : string and you don't include string, the compiler, when it attempts to compile your code, will be like, I don't know what a string is. And it'll give an error and not compile. Anything else? Okay, so talking about strings. This is more or less C's equivalent to the Python string class. If you want to use strings, you have to include string. But one of the big differences between Python strings and C++'s strings are that C++'s strings are mutable. You can actually change the contents of that string, where in Python, the contents of a string are immutable. You can't change them. So constructors are how objects get made, and there's many different ways that you could construct a string. If you just say std string my string, this is going to call the string's default constructor. And if you follow these links here, you'll get brought to the page in the C++ reference library that talks about them. So do follow those. I may not list every single possible constructor that exists inside of the that class, but I'm listing the most common and useful ones that I found. Oops. So if you want to initialize some string from some C string or a string literal, you just put it inside the parentheses. So this would create a string whose contents are Matthew. If you want to make a copy of a string, you can just inside the parentheses put the string that you want to copy. You can also copy only a subset of that string. So here I'm starting copying from name. I'm copying from 0 up to but not including 4. So 0, 1, 2, 3. So that would just get Matt in there. If you do, you can also do a fill where you say how many characters do you want and then what that character should be. So this would make 3 Z's, Z, Z, Z. You can also copy a portion of a name by using an iterator, which we'll talk about a little bit later on. But here I'm saying start at 4 elements past the beginning of the name and then go up to but not including the end, which is the end is technically 1 past the last character. So I'm going to start at 0, 1, 2, 3, 4, the H, and go and include the H, the E, and the W. And so this would turn into HEW. Yeah. Correct. Strings are class objects, which do have methods defined on them, which we're going to get to on the next couple slides. The classes do not exist in C, so no. There is something that's referred to as a C string in C, which is an array of characters that ends with a null character, right? It's not really a data type, it's just a convention. Any other questions? Yeah. So the default constructor is the constructor for that object that takes no arguments. Notice that when I'm calling the default constructor, there's no parentheses here, which is really huge. If you do the parentheses, you're probably going to get an error from the compiler about that method does not exist. And so here, the default constructor for the string, again, the constructor for the string that takes no arguments is the empty string. So there's a difference between just declaring this variable right here, my string, it's a class and it does have a default constructor. Its value is not unknown. It's not undefined. It is going to be the empty string because we call the default constructor to make my string the empty string. Yes? So here I'm creating a new string that's 3 characters long, and all those characters are Z's. So you'd get Z, 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 Z for sleepy. No, it's just 3 Z's right next to each other. Any other questions? Yeah. The range one? So the range one is very similar to the substring one, in that you specify a position as to where to start at, but it's based on, you give it an iterator as opposed to just a number. Strings have a method called .begin, which gives you an iterator to the first character in the string. And then they have end, which gives you an iterator to 1 past the last element in the string. So for example, 1 past name would be whatever happens to come after the W in Matthew, but it doesn't exist, and you should never attempt to dereference an iterator that's at the end. So here we say go 4 elements past the beginning of name, right? So the beginning of name is M, so we go 0, 1, 2, 3, 4 to the H, right? And we go up to, but not including the end, so we get the H, the E, and the W as the contents of Hugh. Like, what do you mean by the end? I got the W, right? Remember, end is not a valid position. It's 1 past the very end. No, it's not in bounds.
Like, waiting.
Like the entire string?
The offset, the 4.
So it goes up to, but not including 4, but 4 is the H. 0, 1, 2, 3, 4 is the H. We still use 0-based indexing, just like we did in Python. So I do get I do get both the T's. I don't get the H, right? Oh, 0, 1, 2, 3, up to but not including 4. Change the 4 to a 5. It's not inclusive. The end is not inclusive, right? So if you wanted to include it, you'd have to do, +1, so 5, and that's how you get the H as well. Any other questions? Yeah. We'd have to go look. And so, yes, if you delete the 4, you can just say where to start at, and it will copy up to, it will go all the way to the end. So if we go back to this guy right here, oops. And if we had removed the 4 from here, it would copy the entire name over. Any other questions? Okay, some string methods. There's .size and .length. They both do the same thing, and they tell you how many characters are inside that string. String.empty returns true if the string is empty. String.clear will make the string empty. It'll delete everything inside of it. Again, remember, strings are mutable, so you can change their contents. String bracket I and string at I both will give you the ith character in that string. One of the major differences between the two is that if you go out of bounds with string at I, what's happens is going to be undefined. You might get a segmentation fault. You might change something that's there. I don't know what's going to happen. It could have different behavior on different machines. But if you stir at I and you go out of bounds, the at method will throw an exception, and the compiler will report, or your program will report that error as that it went out of bounds, which is probably what you want to have happen. So my recommendation to you guys is to prefer to use at over square brackets, because the at does bounds checking. Make sure that you are in bounds. We should also mention that the brackets and the at, you can use those to set the character at that position. So if I do something, like back here, I could do something like name.at 0 is equal to n, right? And that's going to make my name become Matthew, right? You could also do it with the brackets, right? Name.at or bracket 0. And again, you can do anything else besides 0 is equal to like maybe a B or something. And then name would be Matthew at that point in time. Some of the other ones that are interesting to look at is if you do name at 7, it's undefined. I don't know what's going to happen here. If you try to change that to be something, I don't know what's going to happen. You could get a segmentation fault. Something weird might happen. I don't know. But if you do like at 7, then it will throw an exception and you'll get an error because 7 is out of bounds. Because again, the 0-based indexing. And then clear would make the string empty. So when you call empty, it would be then true. Any questions? Okay, some other methods. There's string.front, which will give you a reference to the first character in the string, and string.back, which will give you a reference to the last character in the string. Since you're getting references to these objects, right, it's just another name for that character, you can use front and back to modify the first thing or the last thing in the string, as well as read what's there. Pushback will add a character to the end of the string, and popback will remove the last character from the string. So again, here's some examples. So here's home. Home.front is H. Home.front equals N. It's now going to be gnome. Home.back would be E. Home.back equals S. It's now noms. Home.pushback, it's now nomsy. And then if we did popback doesn't return the character. It just removes it altogether. It's now noms. Right back again. String.at and the string bracket also do return references. That's why we're able to do the assignments over here and have them actually change. Any other questions? Okay. You can add two strings together just like you could in Python. You're going to create a new string that's formed by concatenating the two strings together. Also, plus equals works. You can't multiply a string by a number, though, to make it repeat. That does not work inside C. String.erase allows you to remove characters from a string. You give some position to remove, where you want to start at, and then how many characters from there you would like to remove. And it's going to erase those characters from string beginning at position, counting, and it'll remove num pause from there. If you don't give a value for pause, it's going to default to 0. And if you don't give num chars, it defaults to end pause, which means go all the way to the end, taking everything that comes after pause. There's also string.insert, which would allow you to add other strings or other characters at some specified position inside the string. This is like super duper overloaded, so I'm going to go to the web page on it so that I don't have to include it all here. String.erase also has an iterator-based version as well. If you give two iterators, it will remove everything beginning at the first iterator up to but not including the last iterator. So here's insert. The first one that you're given is a position that you would like to insert at, and then a string. And then it's going to insert the string at that position. There's also substring, so you give some position, what string you want to copy, what position inside the second string you want to start copying from, and then how many elements from that second string you'd like to copy. If you don't specify a value for sublen, it would copy the entire string over, or everything from after subpause. There's examples down the bottom. You can copy from a C string, you can insert a C string. For fill, you can say some position that you want to start inserting at, how many characters you want to insert, and then what those characters should be. So just a single character repeated that many times. You can also, for this one, can also accept an iterator as opposed to a numerical index. You can give it a iterator and then just a character to add as well. And then if you give it 2 iterators, you can say some iterator where you want to start inserting at, and then some other iterators as to where to add the things. So you can see some examples down here. Like where that string gets inserted is basically right before the index. So if you do like string.insert at position 2, before index 2 is where your string will be added at. So we use string.insert 6 string 2. So if we count over here, this is 0, 1, 2, 3, 4, 5, 6. So right before the Q is where they're going to add string 2, right? So to B, and then it's going to add in the. Does that make sense? This one is going to do some substring from string 3. So in string 3, it's going to start at position 3, 0, 1, 2, 3, the not, and then do 4 characters starting from there. So 1, 2, 3, and then up to, but not including the space probably. Or no, it would do the space. So you get not space. You can insert some string literal or some C string. But again, they're doing it beginning at position 8, and then they'll be taking everything up until the end. Again, they're just inserting a string literal, but the entire thing. They did the single character beginning at position 15, and they made it repeat 1 time. If you do an iterator, they said go 5 characters past the beginning and add just a comma. Here they said insert at the end. Right, so it's going to go right before the end, because remember the end is out of bounds. 3 periods, and then they're going to insert, again based on some other iterators, iterator plus 2, which is wherever this insertion happened to be at, string 3 dot beginning, string 3 beginning plus end, which would be the or. And so they finally end up with to be or not to be. That is the question. I know there's a lot of stuff with inserting, but if you ever have to insert into a string, come back to this page and pick which one you want. Do you want to insert just a string and you want to insert it at some spot? Pretty easy, right? If you're doing some of the more complicated stuff, like I only want to insert some substring of this string, it's a little bit more complicated, but definitely doable. Questions? Yes? Mm-hmm. Yes. Oops. fname.erase. So you start at position 7 of oh, this should not be fname. It should have been full. Oh no, wait, never mind. No, it should be fname. So if you look down on this line, right, I added lname to Matthew. Now it's Matthew Butner as one string.
So like variables are different.
Oh, well, that's just a typo, I guess. Right? Sometimes the punctuation gets messed up because I'm typing directly in here. Was that just your question? Like,
yeah, that's
okay.
fine.
Anything else? Yes. I do not expect you to have these memorized by heart. I will not test you on these memorized based by heart. I expect you like, oh man, I need to figure out how to insert something into a string. And you Google C++ string insert, and you get brought to that web page, and you're able to understand what's posted there.
For your full name,
Hold on, I got 1 more minute left. Yes.
So the Matthew Butner would be going together. There would be no space, right?
There would be no space, correct, in the full name. If you wanted to make it a space, you could add like a space in between by like doing quotation marks.
And then starting at 7 and goes to the end.
Because I didn't specify how many characters to erase, yes, it would erase until the end. I will see you guys again on Monday. Hopefully we'll eventually get enough known so we can start doing something interesting in our programs.
Have you put in a